Hey everybody, welcome back to the shop. So I got kind of an unusual tool here, tool bit holder. It's a Wimberley tool bit holder for high-speed steel. And I picked it up a few years ago at our local flea market from a retired machinist that I see out there quite often. Let's go to the bench and talk about this thing and do a little bit of testing. So this is the tool bit that came with it, and it's really not the right one recommended, but it does work good. I have used it a few times, but not a whole lot. But if you look at this holder, so it's kind of like a tangential type tool holder where the back rake is already built in and the side rake is also built in, or well, skew angle, I guess probably be better terminology. So yeah, and it holds a 3/16 high-speed steel tool bit. It's really intended to be used with an AXA style tool block, quick change tool block, or any similar type tool block. It would probably work fine in a four-way tool post as well, although you'll have to make some kind of a block to hold it when you're grinding the bits, as you'll see in a few minutes. Here's their website, and it's kind of interesting. So they're primarily a photography type website, and they make these high-end gimbal type mounts for the big telephoto lenses, like the wildlife photographers and such use. But they also sell this Wimberley tool holder, and their name is Wimberley, father and son operation. Let's go to the tool holder here. Yeah, so there you go. 59 bucks. I'm not sure if that includes shipping or not, but I think you get the tool holder, one pre-ground tool bit, and the instruction manual. They are US based. They got a really nice instruction manual that you can download in PDF form. I think it's like about 25 pages or so. I don't know what brand of high-speed steel blanks these are. These have the black oxide coating, which I really don't like. I'd prefer the ones with the shiny ground surface. So what I did to prepare is I ground one side on the surface grinder to get a real clean, smooth edge on one side, which will be the top. Okay, they recommend having about at least 3/4 of an inch stick out when you do your grinding, and you want to make sure that the back end of the tool does not go below the bottom of your tool block. For obvious reasons, it's going to throw your angle off. All right, so I'm using a tool bit grinder, which makes it a little bit easier. You can use a conventional bench grinder. The setup is just a little bit different, and they show you how to do that in the data sheet. So I've got the table tilted back at 8 degrees, and I've got both tables the same way. Okay, I've matched them both with a protractor. I'm using a green wheel, and I know that's not ideal or correct for high-speed steel, but it's all I got. I've been looking for an aluminum oxide wheel, but they're not easy to find for these grinders. Okay, so then the next thing you got to do is create some layout lines here. Okay, and these are 5 degrees back this way and 5 degrees back this way. And the included angle here would be 100 degrees, all right? And you're just going to do 2 grinds. You're going to bring the tool bit in like this. And I've just been doing it by eyeball, just, tracking my witness marks here. So you want to, this side will be the most grinding because it's a longer length. And then you grind this side, okay? Important to not let your holder rock, just keep it flat, all right? Okay, so that's our rough grinding. Okay, I'm going to take it out of here and then hit the top with the hand hone. All right, I got a diamond hone. I'm going to take this over to the sink so I can do it with some water, but I'm just going to lay that flat on there and just work it back and forth a few times. This is number 1200. I don't know on a diamond if is that 1200 grit or 1200 microns. I don't know. It is what it is. All right, so I knocked the burrs off with the hone. That's actually got a pretty nice finish. You could probably use it just like this, although we didn't put a nose radius on it. We'll do that with the diamond wheel. Okay, so let me put it back in the holder and we'll touch it up a little bit with the diamond wheel, and this one's ready. So this side's set up exactly the same, 8 degrees. I got the same angled guide lines drawn on here. I don't know what grit diamond wheel this is. This wheel came on this grinder when I got it secondhand. It's a pretty fine grit. That's all I know. All right, and then for the nose radius, what I like to do is just shut off the grinder and then just give it a little bit of a radius while it's coasting down. That should be sufficient. Okay, like I said, I am no expert. I'm just following the data sheet on how they recommend you grind these. So just a little bit of honing on the top, and I did a little on the bottom because there was a burr hanging off the bottom also. But all right, so there's our two standard grinds, if you will. On the other end here, I want to grind the roughing tool geometry. Let me show you that. So that's this one here. So it's, yeah, I guess you'd call it a roughing tool. You know, they call it the positive rake tool. All right, so let's see if we can do that. All right, hopefully I got this right. You're supposed to go 45 degrees from the face of the wheel with your layout lines. That's going to bring us in something like that. All right, so I actually set up my miter gauge for this. It's a lot easier. Hold it against the miter gauge. Well, that looks pretty good. Okay, so what I'm going to do next is these little relief chamfers. I'll do that off camera. I'm going to do that with the diamond wheel. All right, this is going to be the Wimberley tool cutter with the roughing grind. This is supposed to be the workhorse hogging, metal hogging grind. Okay, so we're going to take a 30 thousandths depth of cut, 6 thousandths per revolution feed, and we're running about 300 RPM. We're doing it dry. Alright, so we're gonna... It's cutting a nice long stringy chip. It's cutting real easy. this is just mild steel. Alright, it's handling that no problem. Okay, well the chip is a little stringy, but they're easy to pick up. The finish is not bad really for a roughing cut. So now we're going to try the standard configuration or standard grind. This should be more of a finishing type cut. So we're going to go a little less on the depth of cut, but we're keeping everything else the same. Touch off. We're going to take 15 thousandths depth of cut, which will be 30 thousandths off the diameter. Stringy chip, just like before. Stop it right there. Okay. Definitely a much nicer finish. Yeah, it feels really good. Alright, so what I want to do now, I want to compare this to the shear tool. I made up a shear tool. Let's take a cut on this area. Well, before we try the shear tool, let me finish this cut with the tool post locked. Rookie mistake. About the same. It is a nice finish though, for mild steel. Alright, change of plan. Before we go to the shear tool, I've got a conventional high-speed steel cutter in here. Let's just try this one and see what the difference is, if any. I can see the chip formation is a lot different right away. Not curly at all, just long and stringy. Alright. Finish is nice. Let me get some pliers. Get that out of there. That's a nasty chip. I would call that finish slightly better than what we got with the roughing tool on the Wimberley, but our depth of cut was not quite as deep, and we do have a little bit of a chip weld right there. Let me see if I can fix that, and then we'll take another cut. Alright, we're going to touch off here. We'll take the rest of this on out. Except this time we're going to use a little bit of oil. On going into this heavier part. We're going to keep on going into this heavier part. Alrighty. That is some ugly chips. And about the same quality of finish. Alright, we're back to the Wimberley, and I turned the tool around so we've got the standard grind. I slowed down our feed rate. We're down to 4 thousandths per revolution. And we're going to take a 10 thousandths depth of cut, or 20 thousandths off the diameter. Let's see what kind of finish we can get. And we have oil. That's a pretty nice finish for mild steel. Let me get set up with the shear tool. We'll compare that. Bring you right back. Here's a look at our shear tool. And I just ground this up. It has not been tested. So the angle is probably like 25 degrees or so. Okay, shear tool. I'm just going to do a little bit in here, and it's going to be a very light depth of cut. That's all they're made for. And let's just give it a little bit of oil. Oh, there we go. Let me come back. Hard getting the depth of cut starting in the middle like that. Looks like it's working pretty good. And then let's go. All right. Paper towel leaves lint on there. That's pretty nice. And let's see where we cut. Yeah, right here. Okay. Definitely the best finish of all the tools. And then we've got these interesting chips. Okay, let's compare. This is a traditional high-speed steel turning tool. Let's see, let's come in here. We'll touch off in here. Start from there. Just going to touch off and let it run. And we'll give it a little oil. Well, that's a pretty rough finish. Yeah, so the Wimberley definitely had a better finish, although the old traditional, which I'm not sure where I put it. Let me go grab it. Yeah, the old traditional did a pretty good job also. I guess because it's got the higher rake angle. All right, well, it wouldn't be fair unless we compared it to carbide, so let me see what we got for carbide. All right, let's compare to a Trigon style carbide. And I got a fresh edge on here. I've increased our RPM to 500 RPM since it is carbide. So let's touch off. We'll try to take the same 60 thousandths-ish cut. 60 off the diameter. And about the same surface finish that we were getting with the roughing tool. Maybe a little bit better than the roughing tool. Definitely more manageable chips. All right, let's try a CNMG for comparison. Shorter chip. Finish looks good. We'll let it run to the step up there. That's pushing it a little too hard. In fact, we pushed the material back into the chuck. Although the finish was looking good. Yeah, look at our chips. They're bright blue. All right. All right, we're back to the Wimberley. I put a new tool bit in there with the standard grind. We're going to take a little lighter cut and a little slower feed rate. Happens here. Probably more realistic of how you would use this. You're going to step up a little bit right there. Take it kind of right to that mark. Yeah, that's a pretty decent finish, you know, for mild steel. We could probably get a nice finish with the right combination of carbide. You can see it was looking pretty good here, but we kind of pushed the limit on that. All right, we're going to try aluminum, and I think this is where this cutter is really going to shine. We didn't try the facing, so we'll try the facing operation first. Yeah, really nice. Let's take one more pass. I don't know how well you guys can see that or not, but I mean, that's like a mirror finish. All right, let's do a turning pass. Oops. that's beautiful. I think that's where this tool is really going to shine, is on aluminum. You can't get any better than that. That's awesome. Let's compare this CCMT indexable cutter on the aluminum versus what we just did. Yeah, not nearly as nice. All right, one more test before we put a fork in it. So I just put a fresh hone edge on the on our traditional high-speed steel cutter. So let's just do a comparison here. I'm going to try not to bump the tripod. You guys are right there. Pretty hard to tell the difference between the two. I think this one is a little bit better though, but not, I mean, they're almost dead nuts. But this one was harder to grind. Well, I had fun putting this thing through its paces. I wouldn't call it earth-shattering. You know, it's giving good results. I think the biggest advantage is just how easy it is to grind the bits. I mean, you're just looking at grinding two facets is all you got to do, and you don't have to take it out of the tool holder, which is nice. So if if you're in the middle of a project and you need to touch up your grind a little bit, you can just pop this out, go over to your grinder, boop boop, and be right back to work. And I got to make one of these shear tools, so I've been wanting to do that for a while, so it was kind of fun to get that made up. Also, being able to face and turn without having to reposition your tool post, that's a nice plus as well. I did grind a round nose bit, but we were running out of time. This video is getting way too long, so I didn't get to try that. We'll try that somewhere down the road. I think that'll work fine as well. All right, well, thanks everybody for stopping by, and we'll catch you on the next one.